This is off a spindle moulding machine, and it's the mounting base for a power feed unit which rides up and down on a pole here, and you can adjust it to whatever angle you want for feeding the wood in against the spindle head. The original one broke across here. They did attempt welding it, but with it being a cast iron part, the weld didn't take too well. The patient did not survive the procedure, so they've had to go and buy a new one. And the problem is this one has an internal diameter of about 58 millimeters. I'm getting 57.9-ish, so it's about 58 millimeters, and clearly in order to fit a 40 millimeter post inside it, this needs reducing down with a collet, split collet obviously, so that we can tighten it up and clamp it. And being a bunch of woodworkers, they brought around a piece of beech and said, can you stick that together and make a collet out of it? And well, no. You could, but it wouldn't be particularly good. So hunting around in my material collection, I found a nice billet of high density polyethylene which would do it. It's plenty wide enough, and I just need to turn that down and drill the inside out, but of course that's quite a lot of material to remove. It's going to take a few hours to get rid of all of that. So since it wasn't urgent, a better option would be, let's buy a piece of metal that's the right size. So literally 2 minutes of searching on eBay for some 60mm aluminium tube, 10mm wall thickness, which means the inside diameter of this should be 40mm, which is what we require. And I'm getting, what have I got there, 40.01, so I haven't really got to do anything to that internal bore there. All I've got to do is turn this down literally 1mm on either side, a little bit of a step at the bottom because there is I'm not sure if you can see it, but there is a lip down here and another lip at the base. And the first lip is, I think I measured that at 75, whoops, missed it, about there. It would help if I zeroed it, I suppose. Let's try that again, because I'm pretty convinced it's 75, 76, and then the lower lip, which I think is a 45mm, is at 90. So what I've got to do, and this piece is 100, so if I've got my 100mm pipe with a 10mm wall thickness, I've basically got to take this down to about 45 for probably, well, if that's 75 up to here, then I'm going to have 25 overhanging there, but I want to come back a bit, so maybe make that 15. So I'll take all of that out on both sides, leaving me with a very small lip at the top, and then I need to come in, what was that? That was 75, 85, so if I bring that in round about, I don't know, 10mm or so that way, then that should just drop in. And then all I've got to do is split it down the centre, which I'll do on the milling machine, and I've got an old Imperial cutter here which is deep enough to go through the whole lot, so just buzz that through. I think this split here is about 5mm, and that's close enough. It's Imperial, but it's probably, I don't know, 3/16, something like that, 4.8mm. So that should do the job. So it's relatively quick. Just put that in the lathe, turn it down, turn a little step in here, clamp that on a V block, I think, on the milling machine, because there's going to be an overhang here, reference off the centre, and just buzz back and forth, and that should be it. So pretty quick and simple, but we'll see if anything goes wrong. Right, well, before I get too far into this, it occurs to me that I need to get this centre part pretty accurate to that, otherwise the spindle in it isn't going to sit true, and I haven't got a centre that's big enough to take this, so I'm going to make one out of a bit of plastic. I've no idea what this is. It feels possibly like a nylon or possibly an acetal. Feels slightly more like a nylon, the colour of it looks a bit nylon-y. So anyway, I'm just going to chop a bit of this off, drill it through so I can mount it on a bit of 10mm threaded bar, and then just taper the edges so that this will sit in there and A, keep this aligned perfectly on the centre, and B, give it a little bit of support at this end. So we'll do that first just to be on the safe side. It may or may not work, but I don't think it's going to hurt it. So I'll get that chopped, put in here, and we'll just drill that out quickly. Well, I don't know what this is, but it's pretty weird material, because it was actually melting and dribbling just putting it through the bandsaw. It says at the other end 4SGC, but I have absolutely no idea what that is, and there's no other markings on it, so it's not a nylon, I can say that, and it's probably not a dowel rim. It's weird, but anyway, we'll see if we can turn it without it melting all over us. Well, that was a whole lot of messing around just to get this running true down the centre. I've slackened off the jaws here, because obviously this isn't live, so it's not rotating, but with a little bit of pressure that's quite good. But I think I'll take this back anyway, face off here, mark up 85mm, and just take a quick skim off here and get that down to size, and then we'll put a 15mm step here down to, I don't know, 46ish, and that's most of it. I'll probably face off the other end and maybe just put a little taper on them to tidy it up, and then we'll slit it. So yeah, okay, less messing around, more cutting. Okay, let's see where we're at, and that is 58.3, so I think I'll take that down to 57.8, because it could open up when I slit it, so another couple of passes and we'll call that bit done. Right, and that's, oops, 48.5. I think I need to go down to about 46, so a few more passes on that, and that should be pretty close. Well, it's not the best bit of turning I've ever done, but it looks reasonably good. It's polished up quite nice, feels smooth, no rough edges, maybe a little bit of a deburr there, but worry about that. Does it fit? Ooh. Yes. Oh, yeah, actually that fits pretty well. So that should do. Great, now all I've got to do is split this, and we'll see if it expands, but I'll worry about that if it does. So yeah, over to the milling machine. Okay, I've set this up on the milling machine on a V-block. I'm just clamping in from either side. I've not bothered referencing any of this, I've just eyeballed it in because it's only a slot. It doesn't need to be enormously accurate. I think this is a little bit safer than doing it on a table saw or a router table. I mean, you could hacksaw your way through it, but it's going to be a bit ugly. So I'll use the tools I've got and we'll do it with the milling machine. Get the centre point I've got in here, if I can zoom in without destroying the focus and everything. This is a 0.9mm dental burr. It's a pear-shaped, and I haven't got any magnifying zoom lenses on here to get any closer, but this goes down to an absolute fine microscopic point. So all I've done is come in 10 microns at a time and just whisked back and forth across here until, with the aid of a jeweller's loop, I can just see a tiny scratch appearing on the surface, and as soon as I've got that scratch I know that it's at the highest point. So by referencing off the centre of that scratch mark, I know I'm roughly at the top, at the dead centre of this. So that's now set up, and I'm not going to bother with any CNC work on this as such. I'm just going to drop in here with a slot drill and just cut across manually and keep going down. There's plenty of clearance underneath, so 10mm down, and that will hopefully free us up. So I'll put the bit in and we'll get started on that. Right, I'm going to be using a 5/32 end mill on this. It's imperial, but it doesn't make any difference. If you've ever struggled to convert imperial into metric, the trick I always use is to work in 1/16 of an inch, because a 1/16 of an inch is pretty close to 1.6mm. So this is 5/32, which is 2.5/16, which is 2.5 times 1.6, which is 32 plus 0.8. So that gives us 4mm. And I think if you work it out properly, it's about 3.97. So it's accurate to about 99%, which is good enough for what we're doing. It's only a slot, but that, with a bit of luck, we'll churn through here back and forth a few times and hopefully leave us a nice end. I might just radius the edges, maybe come in with a taper just to tidy that up, but we'll give that a go and see how well it cuts. That wasn't terrible at 60 millimeters a minute on the feed, but it is tearing a little bit, so I don't know, maybe a slightly slower spindle speed. See if that's going to help out. Oops. Well, that didn't work. Alright, well, we broke the bit, but I'm picking out bits of swarf from here, so this material is obviously getting a bit gummy, which is why it wasn't cutting. So I don't know if this is an odd alloy or something. It's supposed to be 6082, but fortunately I've got a spare one of these, because imperial cutters are actually a bit cheaper than their metric equivalent, because so few people use imperial these days. So we'll reload that. Gone back to a higher spindle speed, and I think I'll take a slightly shallower cut this time around and probably give it a little bit of juice just to see, but it is picking up some really quite nasty burrs. That's yeah, going to need a little bit of a clean up. So I'm not sure what's happening there, but we'll try it again. Well, I figured it out after a little bit of messing around. Seems to like it well oiled up, quite a lot faster and not so deep. So that's a 200 micron cut, running at 168 millimeters per minute, with a spindle speed of about 2500 RPM. Although it's slow going, edging my way down, it's cutting consistently well, and apart from where it cuts in at the beginning of each pass, a little bit of chatter there to be expected, but otherwise I'm reasonably impressed with that. So there's the answer: go a lot faster and not as deep. Okay, slight change of plan. I'm actually going to do the taper cut first, because if I go all the way through, this could spring out, and then coming in with a cutter at the end of that's going to cause a bit of chatter, I expect. So this is just a 45 degree, 90 degree total angle spot drill basically, and I'm just going to come in about a millimetre or so and just take that little bit of a burr off. Well, this, I think, is pretty close to the final pass. Right, let's get it off and have a look. The bit is in one piece, and this hasn't really opened up a great deal, probably because it's quite thick wall. So get that out, and yeah, there's still a little bit hanging on there, but that'll wiggle off, I think. Yep, there we go, and there it is. Right, let's clean it up and see if it fits. Oh, it's not too bad, nice and shiny. I think it does need a bit of a deburr on the inside, so I've just been giving that a bit of a scrub with a rounded file. That seems to be bringing a little bit out. Yeah, it's not too bad, there's a little bit around that edge. Maybe just around that a fraction. Yeah, it's not too bad. Right, now is the important bit. Has it expanded? And no, not significantly. There we go. That doesn't look too bad at all. Want to tighten up. Oh, yep, that's squeezing in. So, yeah. Oh, crikey. And it comes out. So, yeah, I think that's pretty good. Looks like it's part of it. Yeah, okay, a bit of blood and probably a black fingernail, but par for the course. Another one off the list.